A very good morning to my dear students of class 7. So this is a continuation video. In the previous video we have learned what is speed and velocity. The distance covered by an object per unit time is called speed, and the displacement of an object per unit time is considered to be as velocity. So the main difference between the speed and velocity is distance and displacement, these words. So also we have learned what is uniform speed. If a body covers equal distance in equal interval of time, we consider to be as uniform speed. Whereas if a body covers unequal distance in equal interval of time, we consider to be as non-uniform speed. Okay. Here in this video lesson we will find what is uniform motion and non-uniform motion. So if a body is moving with certain speed, let us consider a car is moving with 60 km per hour. That means this is speed because I have not mentioned here which direction the car is moving. But when I mention here a car is moving with 60 km per hour towards east, that means a car is moving with some speed and in a specified direction. So we consider to be as the body is moving, that is the body means here car, that car is moving with uniform motion, right? That means speed with specified direction. That means speed should be there and there should be a fixed direction. Okay, so let's see what is a uniform motion. A body is in uniform motion if it covers equal distances in equal interval of time in a specified direction. That means a body is moving with equal speed, that is equal distances and in equal interval of time. So the distance covered and the time interval is same, and the car is moving in a fixed direction. That body means here car is moving in a fixed direction, so we consider it to be as uniform motion. So we say that car is moving with uniform motion. Okay, a body with uniform velocity is in uniform motion. That means if a car is moving with certain fixed speed and the time interval is also same, then we consider to be as uniform motion as to be as uniform velocity. But where in case of non-uniform motion, a body is said to be a non-uniform if it covers unequal distances in equal interval of time. If it is not covering equal distance in equal interval of time, then also we say that it is non-uniform motion. If that body has uniform speed, that means the speed is same, that is it covers equal distance in equal interval of time, but its direction is not fixed, the direction is changing, then also we will say that it has non-uniform motion. That means the car is moving with non-uniform motion. Okay, so this is the basic difference between uniform motion and non-uniform motion. Okay, I repeat, a body is moving with uniform motion if it is moving with fixed speed and in fixed direction. Fixed speed, when I say, that means it covers equal distance in equal interval of time and it is moving in fixed direction, whether east, whether south or certain direction is mentioned. That only we can consider to be as uniform motion. Uniform motion means here uniform velocity. But where in case if a body or if a car is not covering equal distance in equal interval of time, though the direction is fixed, then also we will say that it is moving with non-uniform motion. Okay, again in the second case, a body will be non-uniform motion if it is covering equal distance in equal interval of time but the direction is not fixed. Okay, so what is mandatory? So speed should be same and it should have same direction, then only it will be uniform motion, otherwise it will be non-uniform motion. Okay, so this all notes you will be writing in your exercise book. So in the board you can see average velocity. This is our next subtopic. Before going to average velocity, let's recall what we have learned in average speed. Total distance covered by a body by total time taken was average speed. Okay, if a body is moving from certain point, suppose A to B, 1 hour, and here suppose 2 hour. A body is moving, a car is moving from A to B, covering 3 km in 1 hour, and from B to C covering 3 km in 2 hours, right? So if I say what is the average speed here, then you will say average speed, that means S average. Okay, I am writing here S average means average speed, total distance 3 plus 3. Okay, these are in kilometer, and total time 1 plus 2, that is in hour. That means 6 by 3, 3 1 is 3, 3 2 is 6, that means 2 km per hour. Okay, so this was the average speed. That means in that case what we have done, total distance by total time taken, that was average speed. But here we will find that what is average velocity, that is total displacement by time taken. Total displacement, or you can say total displacement of an object by total time taken. So in place of distance, if you replace the word distance with the displacement, then it becomes average velocity. Now one thing you note here, suppose you are moving from your home to market, right? So the distance between your home and a market is 6 km. So from your home you go to market, again you come back to your home. That means what is the total distance traveled? If I ask, then you will say, sir, it is 6 km plus 6 km, that is 12 km, right? But if I say what is the displacement of yours when you move from your home to market again back to home, that means you say the displacement is 0 in that case, because your initial and final position is same. From home you go to market, again you come back to home, that means the displacement is 0. Okay, so in that case velocity will be 0, because velocity is related with displacement. Okay, speed is not 0, but here velocity is 0. Why velocity is 0? Because displacement is 0. Similarly, if an object is moving in a circular path, that means in rotating in circular direction, so again and again you will be coming back to its initial position. From where you start, again after turning one round, again you will come back to its own position. So we consider to be as displacement as 0. So here also velocity is 0, but speed is not 0. Okay, so keep it in mind, when displacement is 0, velocity is also 0. So next we will see acceleration, rate of change of velocity with respect to time. If a body is not moving with uniform motion, if a body is not moving with uniform velocity, then that object is having some acceleration. That means whenever an object is not moving with same velocity, that means its velocity is getting changed. That change in velocity per time we consider to be as acceleration. So what is the formula of acceleration? Acceleration equals to change in velocity by time. Also, acceleration can also be defined as net force by mass. That means net force means F and mass means m. That means A is equal to F by m. So here you see acceleration has two formulas. One is change in velocity by time, and one is net force to that of mass. That means it is inversely proportional to mass. Inversely proportional means this is in denominator, this is in numerator. If mass is less, so acceleration will be more, whereas if mass is more, then acceleration will be less. Let's understand with one example. Suppose you have two stones. One is very small, let us consider 500 gram, right? And one stone you have 5 kg. So when you are throwing both the stones with same velocity, same acceleration, okay, force is same, then whose acceleration will be more here? You will find the object which is less weight. That means 500 gram stone will move with very high velocity. That means acceleration of that small stone will be more as compared to 5 kg stone. Okay, if mass will be less, then acceleration will be more, and if mass will be more, then acceleration will be less. So therefore it is said that acceleration and mass is inversely proportional to each other. So if you cross multiply, you will be getting as a formula F equals to ma, where m is mass and a is what? Acceleration. Okay, so not only here, you will find that when you shake the mango tree, always the mango, or whether you shake an apple tree, always a mango or an apple or fruits, they come down, they fall down. So this was the major invention of Isaac Newton, right? Why the object is always falling downward, in downward direction? Why? That fruit which is fallen from that tree, why it is not going in up sky? We know that Earth's gravity is pulling that object. We all are being pulled by the Earth's gravitational pull. So whenever any object is falling from height, always it falls in downward direction. Okay, it falls with acceleration due to gravity. That means with the force which is attracted, the force which attracts us towards it, that's Earth's gravitational pull, is the acceleration due to gravity, right? So acceleration due to gravity, when I say, that is A becomes G, that is acceleration which is fallen when the fruit falls down, then that is considered to be as G, and the value of G is 10 meter per second square. So whenever any object is falling from a certain height, it falls with certain acceleration, its velocity is increasing in downward direction, and that acceleration is having approximately 10 meter per second square. Okay, so this value is fixed when object falls from a certain height. So this is just an approximation value. Okay, so this also you will note down in your exercise book. So there is a difference between mass and weight. Do not get confused with mass and weight to be as same. Mass is a scalar quantity whereas weight is a vector quantity. So whenever a mass is multiplied with acceleration due to gravity, then it becomes weight. Okay, weight formula, when I say W equals to mg, where m is mass and g means acceleration due to gravity. Just now we have seen whenever any object falls from a certain height, it falls with some acceleration. That acceleration is said to be as g, that is acceleration due to gravity. So that one, when you multiply it with mass, then it becomes weight, and the SI unit of weight is Newton. Okay, so the weight of an object on the earth is the gravitational force exerted by the earth on that object. So how much force the earth is acting on us, exerting on us, that is the weight of our body. Like if I say the weight of a body is 40 kg, okay, so that means this 40 kg, our mass is attracted towards of earth, that is earth is pulling this 40 kg towards it. Okay, so here we say SI unit of weight is Newton. It is a vector quantity and it is measured by spring balance. That is, weight is measured by spring balance, whereas mass is measured by beam balance. Mass is a scalar quantity, whereas weight is a vector quantity, and weight, the expression of weight equals to mg, that is m is mass and g means acceleration due to gravity. Okay, so W equals to mg. So here you will see the difference between mass and weight. Okay, mass means it is the amount of matter present in an object, whereas weight is the gravitational force of the earth acting on an object. The SI unit of mass is kilogram, that is kg, but SI unit of weight is Newton. So these are the differences which you need to write it in your exercise book. Okay, and below the differences you will find this is spring balance. You see, this is the hook. Here you have to place the load. Here, like you see, one sack is being placed here and the reading will be showing here. Okay, so this is based upon weight, so it is measured with spring balance. Okay, beam balance, when you say that beam balance means in a normal grocery shop you find that when you are going to wait or to bring sugar, they measure in that beam balance. They are having plates. Okay, one side they place the standard stone and in one side sugar. So these questions also you will note down in your exercise book. Choose the correct option to fill in the blank. You can directly substitute the correct answer, no need to write the option. So here are the few questions from the exercises. First you see, name the following: translatory motion along a curved line. So what is that name of that motion when it is moving it in a curved line? A motion that repeats itself at a regular interval of time. See, first answer you can note down a translatory motion along a curved line, that is called curvilinear motion. Okay, we have already discussed in the video. This is curvilinear motion. Similarly, a motion that repeats itself at regular interval of time, that means it is periodic motion. It is repeating again and again. Okay, periodic motion. When a body covers equal distance in equal interval of time, then we consider it to be as uniform speed. Okay, so number 3 as uniform speed. Number 4, speed with direction. This is velocity. Okay, whenever a speed is added with some direction, then it becomes velocity. So number 4 is velocity. Number 5, gravitational force exerted by earth on an object. So what is that gravitational force which exerts on earth on an object? That is weight. Okay, an instrument to measure weight of an object, just now we have learned, that is called spring balance. Okay, so choose the correct answer. This one also you will note down. Revolution of earth is an example of, so this one you will find. Okay, and whichever questions you will unable to solve, I will be solving in the next video, or let me know, or as soon as the school gets reopened. Okay, so these all questions you will copy, choose the correct option along with true or false. Okay, a toy train moving around a circular track has rotatory motion. So this statement will be false, right? It is a revolutionary motion. So similarly you will be solving this one as true or false. Okay, and choose the correct option. Choose the correct option. Also you will be writing direct answers. Okay, here 3 questions are there, 1, 2, 3, and here few questions 4, 5, 6 and 7. You can pause your video and you can note down the questions. Okay, and while looking this video you will turn your phone horizontally, not vertically. Okay, then only you will find the letters are clear. In the next video we will solve some numericals. You see the numericals are placed here. This is the exercise numericals. So numericals you no need to do now. In the next video we will solve some numericals as well as some question and answer and difference between. Okay, so in this video only up to this much.